Welcome back. So, is everybody refreshed? Everybody properly hydrated and properly caffeinated? Show of hands, who's properly caffeinated right now? Awesome. Okay, for our next talks, we are taking a dive into music. Two very different subjects, but both musically related. Our next speaker is Felipe Ignacio Noriega, and he has a very interesting background. He is both a musician and a programmer. He's actually graduated from the conservatorium, but also works as a software developer. And he's going to talk to us and show us a way to make music and functional programming meet. So, can I get a big hand for Felipe?
Thank you. Hello, welcome everyone. It's nice to see you all here. And thanks for the organization for inviting us. It's nice to be found, even if we have like 10 views on YouTube and stuff like that. So thanks a lot. It's cool you found us. Yeah. So I'm going to talk to you about this project, the Codeklavier, which I'm doing together with Veinberg. She's a pianist. She's actually the mastermind behind the project, and we're sorry she couldn't be here. The idea was to actually show you the project, demo the project for you in real life with the piano. But okay, so given she's not here for personal reasons, I'm going to do my best to, do my feelers alone. So I'm going to talk a bit about our background, then the Codeklavier. Of course, the live demo will skip it, and I'll replace it with some videos we have. Not a lot. I'll just play a little bit too, so you get the idea of it. Then, through the history, I'm going to talk about how we started, the different versions we've made, and how that led us to lambda-calculus, and how we're applying that with the piano. So more going into functional programming. And then the relationship between music and programming, and what can the one mean for the other? What can we learn from them? And then ideas about the future of this project. Maybe you guys have also ideas. OK, so there you go. Well, I already put it, so let's just put it in there. So I met Anne. There she is, at the conservatory. We both did the last year of the bachelor, I think, and then the master's. And her research was about piano and technology. And my research was about being a laptop musician. So how can you be also accepted in a conservatory, even if you don't play an instrument, only the laptop? Like, can that be considered an instrument? Can you be considered a musician, just like a cello player is a musician? And we kind of, she being into technology, me being into coding and software, we thought, OK, let's make some duos. So we started meeting every Thursday, I think, after school. And we were just improvising for 2 hours, just like, OK, here's a piano, here's a laptop, there's a sound, let's go. And we were doing something, we didn't know back then it had a name, but nowadays it's called live coding. Maybe you guys know about it. So it's when you basically make music with code, but you always show your screen, you always show to the audience what you're doing so they can follow the process and the algorithms. And back then it was more in the academic circles. Now it's more, I wouldn't say mainstream, but you could find concerts of it constantly. And we were 3 of us, so it was Anne, me, and the recorder player. And then at some point the recorder player decided not to go on, but me and Anne really liked it, so we went on. We made a duo out of it called Offs. And we were just basically presenting for audiences, improvising for audiences, piano and software and live coding. And then at some point, Anne said, well, this is nice, but we're falling into the same patterns. We even presented this in the ICLC, the first one, the International Conference on Live Coding, which was in Leeds. And we thought we had kind of squeezed all the juice out of what we were doing. And then Anne came with the idea, well, let's go to the next phase. What can that be? And at that point, she started to do a PhD also, so she was very research-oriented. And then she said, hey, what if we can make of the duo a solo act? So can we actually have me as a pianist make the algorithms, make the code? And I immediately thought, whoa, this is a really, really, really good idea. So let's just look into it. Let's start researching. And we also got a starters fund from the creative industries. They're here in Rotterdam, so then we could really, fund the days to research on this. And back then when we did the research, then we found out already there from the 19th century, you have these kind of devices. This one's called the literary piano. So basically, some people were already researching how you can change like the normal QWERTY keyboard or the normal keyboards with any disposition. How can you put like a instrument or a musical keyboard and see if you can type faster or you can make patterns, and that means something. There's another device called the stenophone, which also has another kind of ergonomic disposition. And it was all about speed of typing back then, but it's interesting to see that it's already almost a piano keyboard. So then we thought, okay, so the first thing we need to do is type. Can you type with the piano? And we did a JavaScript prototype back then, which I can show it to you. We called it Hello World. That was okay. Let's do the Hello World. Can you actually type Hello World or something? And I'm going to play a bit of what it is, and then I'm going to tell how we did it very briefly. So maybe you guys can get it already from looking at the video. Let's see. Okay, so I'm going to just stop it there. I think you get the idea. Thank you. So, thank you very much. Thanks for dimming the lights. So that was really nice effect too. So this was Hello World, and to our surprise, it was very well received on audiences, probably because people can follow what she's doing, they can follow her mistakes, they can see when she's frustrated. You can very easily understand what she's typing or playing, and you see immediately the effect. But for us, or for me at least, in a technical perspective, this was just way too simple. This was very far from coding with the piano. This was just replacing the interface of a keyboard with a piano keyboard. So what we did in this one, at some point we ported it to Python, and then we used Pinput, which maybe some of you know. You can emulate keyboard strokes and the mouse programmatically. So it's very simple. I have here a little screenshot, but let's see. There. So we have this kind of configuration file, initiation file, which we're grabbing MIDI from the piano. So we do this with electric MIDI piano. So that's the protocol we use to analyze. And if it's an acoustic piano, we have this device called a key scanner, which Andrew McPherson from Queen's University in London built, which basically turns an acoustic piano into a MIDI piano. You get MIDI messages with some sensors you put on the keyboard. And then, so we're getting a stream of notes, MIDI numbers you get in the piano from 21 to 108. That's kind of the pitch. And you also get the velocity, so how hard it's played, and also the delta time, so the interval between one note and the other. So that's the three things that we analyze. With Hello World, the only thing we analyze is which note is coming in. And basically, we map a note to a character or a symbol. So if she plays 22, that would be the second lowest note. Then she gets dot tempo. She has somewhere the H, the E, the L, etc. So she could type Hello World, And in a way, it's very transparent, and that's why it works, I think. But for us, it was really not so musically interesting, because she's just playing almost with one finger. It was very simple. Actually, our plan was to let some of you try it here. But we don't have the piano, we don't have Anne. But then we thought, okay, this is very far from actually interpreting music as programming, or making a programming language for music, which was kind of the dream we were having. We need to look deeper into what music is, and how can that be translated into computations. And then the next step we went to was, okay, so we did Hello World, it works, got well received. let's try to do multipets now. And this is a wordplay between snippets, so code snippets, and motifs. So if there are any musicians here, you probably know what a motif is. And if you don't, then it's a motif would be like a unit of music, which could be a melody, could be a chord, could be a sequence of chords. So it's like a pattern, a musical pattern that gets repeated, and then it means something. That's a motif. Yeah. So what we did is that instead of having one note that makes a character or prints a string, then we would have like a motif. The Codeklavier would recognize certain motifs, and that would call a snippet. So a snippet would be printed. And then this gave us the opportunity to start doing something a bit more like block programming. So she would call a snippet, and then she could call a different snippet and a different snippet. And sometimes the order would make the algorithm, and she could change the order of them depending on which motifs or motif she's playing. She could call different snippets, and most of them were interchangeable. So this was, to us, feeling a bit more musical and also more interesting in the sense of programming. So what we did for these ones, for example, was we had melodic recognition, which that means that the stream of notes that were coming in, we were checking if we had in the ini file also like a defined motif. So we say maybe if note 22, 23, 24 come in that order, then it gets recognized as a motif. And those were predefined, so we had like, okay, melodic motifs with also chordal motifs, so notes that are played simultaneously. They could be kind of looked up in the original predefined motifs, and if they matched, then the Codeklavier would say, oh, there's a motif. And then it would also have another mapping to a snippet, so that's how it would get printed. And we also thought, like, okay, how can we make numbers that is not just by choosing the note that prints a number? And we found that we could do that with tremolos. That was the pianistic version of it. And a tremolo is when you repeat a note, 2 notes or 3 notes very fast, like tilililililili. And you can have like very close notes or very far away notes. And then the Codeklavier would say, okay, that's a tremolo, because I hear a note being repeated for a certain time. And then it would just calculate what's the lowest note and what's the highest note, and then that interval would be the number she prints. So she could start printing numbers just in a more musical way. I'm going to show a bit of what it is, and then I'm going to go into the next thing we did with it, which was allowing her to define conditionals. So let's see. So this one is multipets. Just stop it here. If you see, or if you can listen to this, it's already way more musical than the original Hello World, which was just like one note, one finger kind of patterns. Now she's making chords, she's making melodies, and that's being interpreted one way or another. We also always had that free code column, which was still the one-to-one mapping, because it works so good. It's like, okay, let's still have that. So she has one note where she can switch to that mode of recognition. But then what was, to me, the next step, or what multipets did for us in our journey to interpret music as computations, was that we could allow her to define her own functions. So basically start making algorithms that branch, start making like if, then, else conditions, and then have some musical results with that. So for example, what she did there, she did maybe, I mean, we heard it, but it's hard. She does like doo-doo-doo-doo. I cannot sing, but that would be like, okay, that means I want to set a conditional. And then she did like a chord, plum, 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 something like that. And that says, that would be, with that one, you choose which result you put that, you would map which snippet of a result if it's true, and then with a different chord you would also decide what's false. So she would say, with a melody, I want to make a conditional. Then the program says, okay, you want to make a conditional. What if it's true? Then she would define, okay, from my library of motifs, I want this one to be true, which was play a gong. And if it's false, it could be something like stop a sound or nothing. The false could be nothing if she didn't define it. And then the last thing to define would be a tremolo, which would be part of the what's being tested. Like in that case, it's like if the range is more than, so the range of in the piano what she's playing, like from there to there. If it's more than 4, let's say, if she did a 4-note tremolo, then if it's bigger than that, then it evaluates to true. So the gong plays. If she plays like in a very close range, it evaluates to false. Maybe there's no sound, or she mapped it to something else. And then we also had a flag in there, which would be like, they could be ongoing, so they would be looping. That's the loop here. So if she set a conditional testing her playing, it would stay, it would be kind of perpetual. And then she had other blocks or conditionals to be able to stop everything or stop all of them. But what we thought was interesting into this is that the conditionals she's defining are not testing the outputs of the program itself. It's not testing like which variables are being set and the values of the different variables in there, but it's actually testing her playing. So she's making conditionals for herself, like can I play 100 notes in 10 seconds? Can I play 30 notes in 180 seconds? And the cool thing is that she decides all these things while she's playing. So for us, this was really getting closer to what we were thinking. Okay, now it seems you're starting to program with the piano. The thing that became also difficult is that once it's more musical, it's also more difficult to follow. Hello World is very easy to follow. For this one, we even tried to do these columns to allow people to understand where she's going, but at least for me, it's very hard to follow. Like Anne is the only one who knows what she's doing in the end in these things, and you know she's really good at it. We also tried with other pianists, and it kind of works, but Motipets still it was still kind of so hard-codedly based on mappings with predefined mappings that it was also susceptible to to kind of falling into the same pattern, or you had a program you needed a programmer to write the snippets. Like Anne couldn't write the snippets. So in this case, it's SuperCollider, which is a programming language for music, but it could be JavaScript. We had also one JavaScript extension, which she's making like some elements in an HTML canvas. And I mean, that's the nice thing about Motipets. You could do anything. It could be any programming language, and then if someone would write it, then there you go. It could be played. But still, it was kind of, Anne is playing, someone is writing the code. She's not really deciding the code herself, So that made us kind of go further. We still needed more. And luckily, I think also before this point, after Hello World, we also managed to score 2-year funding for research, also from the Steve Brings funds and a private sponsor, so we could really take 2 years to go deeper into it. And we also had 2 really good mentors. One was Nick Collins from Durham University in computer music, and the other one was Andrew Sorensen, which maybe some of you know. He was the creator of this language called extempore. And then Andrew was the one who said, like, hey, why don't you start looking into lambda-calculus? And then that was a big eye-opener for us. That was like the brain meltdown too for us, and also for Anne, and for me especially. But kind of the other ones, it was easy to play music, but when we went into lambda-calculus, it kind of started to become a bit complex. But I think it was some sort of complex simplicity in a way. I mean, I'll go into it a bit, but to me, that is really the key to allowing Anne to code and make programs or define computations with the piano. So we decided to, okay, if we're going to do lambda-calculus, let's do something simple. So let's try to do like a very, very simple arithmetic calculator. And you being developers or computer scientists, I assume a lot of you know lambda-calculus, or if you've heard about it, or you like it. Maybe you have your own little notes and you're doing functions all the time. But so we went to defining like very simple functions, kind of the basic elements. So one of them was 0, which is also the identity function, which a lot maybe of you know, which basically is a function that returns the argument, the body. So if you would say here 0 and then a string high, it will return high. Or if you do 0 of 0, it will return 0, etc. It returns its body. Then we have the definition of true, for example, which is a selector function. So it returns the first element of a pair, or false would return the second element. That way we could also then go into defining numbers, which we did it through the idea of successors and predecessors, or successors of 0. So if you haven't heard about it, the successor function is a function that returns a successor of whatever you applied it to. So if you have the successor of 0, you could interpret that as 1. If you apply a successor to that, then you have the successor of 0. So that could be 2. And you can apply that to the successor again, so you have the successor of the successor of the successor of 0. And that would be a 3, exactly. So it was pretty simple in that way. To me, it was like really mind-blowing to understand numbers that way when you're used to, thinking, oh, okay, this is an integer, or, okay. And then trying to see everything as a function, and then understand that everything is a function, and then you can interpret everything as a function. That's the moment that I thought, like, wow, now the piano is really just making computations all the time. Sometimes they mean something, sometimes they don't mean something, but you can literally be applying everything to everything. And then let's hear a bit how it is, and then I'm going to go deeper into it, and then I'm going to go to also what I think was a big discovery with lambda-calculus. So as you can see, this became again a bit transparent, I would say. Like we managed to go back to the transparency of it, but also, I guess, musically a bit more boring, also for Anne. But I think that to me the power of this was that we discovered that now it's not characters that are mapped to keys. Now it's functions, and you can apply functions to functions, and you can get results with that. And it happens that we interpret some of those as numbers, and then what's also really cool about this idea is that with these very basic elements, with the 0 function, the identity function, with false, with the select first, with the select first second function, and then and the predecessor, like with these elements, you can define simple arithmetics, because then you can also define the add function, the addition, just with recursion. So that would be like if you have add x to y, you would define it recursively as apply the successor to x every time you apply the predecessor to y until y reaches 0. And then that way you get addition. And then in this recursive way, you could also then define multiplication, division, etc. And then also the number comparisons. So that logic, Boolean logic there, where we can compare the numbers, or compare anything. You could compare anything, actually. She could have said, like, is 7 greater than 5? And then the Codeklavier would apply the certain functions, do the beta reduction, and then say, okay, I get a false at the end. or it could also, Anne could also say, oh, is true greater than 5? So that would be like a comparison that's weird, but you could still do it because it was untyped lambda calculus, so you could apply this, you could get a function that's not a number, but you do get a function, and to me that was very, very interesting actually. Because now she could really go wild on the piano, and it wouldn't crash. And sometimes things would go good, sometimes not, but it started to give us a bit of a path into how can we bring intuition a bit closer to software programming. Because normally when we are programming, we are definitely not doing it intuitively or not all the time. But when we play music, at some point we just get into this state where we are really, you get into a state where you're not thinking anymore. It's almost like muscular memory, and you're just listening, and there's a stream of thought and a stream of expression. So can that come into software development too, or into writing algorithms? But besides that discussion, the coolest thing also that we had is that we, thanks to lambda calculus and the understanding we gained from lambda calculus, is like we managed to find a way for Anne to define her own functions. So by this point we have like Anne being able to type, that was easy. Anne being able to define conditionals, kind of worked with the block programming idea, but now Anne could define her own functions. So this would be dynamically. This was not anymore looking at an ini file with pre-coded things. This was really on the fly. Anne was deciding to make her own functions. And the way we did that is that the Codeklavier was recognizing ostinatos, which an ostinato in musical terms, those are notes that it's a note pattern, melodic note pattern that gets repeated. And then that would be for the Codeklavier, okay, you want to define a function. And then if she would change the ostinato, the amount of change would be how many arguments you want in the function, so the bounded variables. And then the next part would be like what's the body? Which function do you want to apply to the body? So if after that she would play a zero, the zero function, then okay, you want to apply the identity function. Or maybe she wants to do addition to 2 arguments. So I'm going to show you how this works, and then I can talk a bit about it. Cool. Thank you. Thanks. So that was for us like really the breakthrough. The chord she was playing is in the end the ostinato she used to define it, but condensed in a chord form. So now she could define her own chordal language. It was not chords that you had predefined. It was chords that you make on the fly, and then those just get synthesized as functions, or it would be like the function name. You give a name to the function. In this case, the name is a chord, and she can decide which one. So if she's a jazz player, maybe she wants a jazz chord. In her case, she's more like a contemporary music player, so she likes clusters. But the other thing she could do is, because she was making these functions, she could make multiplications, divisions, whatever. She was very quickly getting like huge numbers, like astronomical numbers, and then we started to get stack overflows. And then we had to look in, we were doing this in Python, so we had to look into, for the ones that want more technical information, into the tail code optimization. And then we first tried to implement it ourselves to also understand it better. And then we used the Funk Tools trampoline wrapper. And then that started to work nicer. She could do like these astronomical numbers again. It would take a bit long sometimes to get the result, but it wasn't overflowing. And so then the question is like, okay, why would we do lambda calculus on the piano? As you know, it's a proven formalism of computation. So if we were able to make lambda calculus with the piano, then you could say like theoretically, she's also making computations by playing the piano. So she is programming with the piano, at least on paper or theoretically. It's a great tool for representing abstractions. Just the way I explained, you can represent arithmetics and numbers and natural numbers. And music also lends itself for this. In music, we also can talk of functions. So normally a chord has a function in relation to other chords. You could represent maybe also the tremolos, as I said, as a function. Like in a way, you can approach musically very mathematically. And that lends itself pretty good to translate it into lambda-calculus. That's something we want to go deeper into, but our funding ended, so we're not working as much in it as we could. And then we think that this could help us bridge computing and music. And of course, yeah, why would you do this? Just for the joy of making it, of course, and for learning. I definitely became a better programmer after this. But I think what we're also trying to do is oh yeah, of course, bringing the piano playing closer to the programming language. You know, that's kind of the crazy wild dream. We don't know if it's possible, but we're trying to get closer every time. But I think what this can give is, you know, what can we learn from music as programmers? Like, there's one interesting thing that happened, for example, with Mo Tippets, is that because she has two hands, she was playing, she can play independently with the two hands more than a programmer can write two programs at the same time. So she was being able to make like two algorithms at the same time. And that, so for parallel programming, this would be very interesting and also very quickly. She's way faster than any of us trying to make two streams of code at the same time. I cannot, you know, I have to make one, then take a big break, and then maybe I can switch. But for her, she was just like, no problem, two things at the same time. And another one is this kind of the intuitive mind, like how musicians really do what they do just from hours of training and muscular memory and more focusing on, you could say, on expression or on emotions. And how can, if you translate that into an algorithm, into a computation, what does that computation mean? What can it mean something actually? Like, can we one day make software by playing music? Can every company have a piano there? Or can we empower musicians to also understand code better? Then musicians also have code literacy, let's say. And this is something we've also been trying, but we were struggling with a bit, but we think it's possible. And then one last interesting thing about this is that, you know, in this kind of feedback loop you get with this kind of methodology is that Anne is playing music, that is creating a program or code, that is creating in itself music or some sort of output that influences Anne to then change the music, because in the end she's giving a performance, which in turn then changes the algorithm. So then you get this kind of feedback loop of both influencing each other, and that's how the performance grows. And we thought that that feedback loop is also interesting to look at. Finally, like the piano numbers in the wall. So that's Giuseppe Piano, who invented the, you know, who found out this idea of successors for number theory, for natural numbers. And then we're thinking like, okay, we could have more complex functions. So go into more complexity. For example, until now, we only have from 0 up. We don't have negative numbers. We could allow Anne to apply also recursion, maybe in a more conscious way. And also more applications than just music making, that would be cool. And then one that we definitely did was with L systems, which these Lindemeyer systems are by a biologist, Lindemeyer, who was trying to make rules or find functions, you could say, of how plants grow or algae work. So we started to use the calculator, the CKalcuLator, to make numbers that actually get interpreted as symbols, and then she would make rules, Lindemeyer rules, that then generate new symbols. So you could have like 1 becomes 1, 2, and then you could recursively apply that. So 1 becomes 1, 2, becomes 1, 2, 2, 1, 2, etc. And then we did with another artist a system with which she makes graphics with the L systems and with the CKalcuLator. We also wanted to show that, but we will not. And the interesting thing, and we also talked about this in dinner yesterday. So normally we use art. No, the other way around. Normally we use technology to create art. There is technological advances, and then we make an art piece of that. But then we wanted to shift that around. Can we use art, to create technology? There, food for thought. And can we one day talk about the musical paradigm in programming, like not just the functional programming or the imperative or object-oriented? Can there be the musical one? And Anne says, thank you. Thank you. Thank you.